Next, third one out of the four, the climate sensitive architecture, construction, sorry. Climate is, I should have actually put it first because the climate was the first of our all concern. So initially, the prominent feature of the Indian architecture was the courtyard architecture, called as the Ekshala, Dishala, Trishala and the Chaushala. So Chaushala is the four quarters or the buildings which is internal a kind of a courtyard, which actually gives an incremental housing principle which is still there. I have a small family, I have a Ekshala, then gradually I have a bigger family, so I can convert that into a Chaushala kind of a thing. And as you all know, in a central courtyard kind of a structure is very, very prominent in our India today itself, particularly the hot and humid climatic zone like Kerala, Bengal and all. Bengal it was almost evolved, I mean now people are not going into that, but still in Kerala there are lot of houses are there which is, they follow this Chaushala kind of a character. If you see the Bengal, Assam and Bengal, this I have just now told in the very beginning that mud housing. This material is one of the best material from the climate responsive point of view of this particular area. This has a, you need to have almost about 300 mm, 300 mm is almost like a 1 feet of thick, and it will give you a wonderful protection from the heat. It maintains a kind of a constant temperature inside, in summer also, winter also, it's kind of a same temperature. The only problem, see, I must say all materials will have some kind of a problem. No material in the earth is having the problem free. Concrete has its own problem, steel is having own problem, the timber is also having the own problem. The unfortunate thing is that our engineers have not actually they always felt that this mud is a very poor material and we cannot improve it. It's material for the poor people, it's material for the people who lived in the village and all, it's a material for the vernacular architecture that let them do their own, but it has its own problem. The first problem is that in the mud building the percentage of opening is very less. Because of some reasons you cannot put, so the amount of windows are less. In this hot and humid kind of a climate, you require larger opening, but still it is less. That is why what we find in our studies is that in the mud buildings, they are very good in the night, but if the humidity is very high, this is going to be a little bit bothering because the air exchange is not that much, number one. Number two, as the opening size is less, the daylight penetration inside the building is less. Number three, as this particular mud is kind of a material which always evolves some kind of a dust, inside air quality is also very, very poor. So these particular 3-4 things are definitely the drawbacks of the mud as a material, but no engineering studies have been actually addressed those, how to improve that one. That is the most unfortunate thing. So those, the external, the long part of the shading part and all these things also came as per the invention. So these are some of the mud house we can see. Even there are double storied mud houses are also seen. If you just go to around 10 to 15, not 10, 15, 12 kilometers from our campus this side, you will see the lot of double storied mud houses also still there, and they are with a good character. Last week, a team from Hiroshima University came to IIT Kharagpur. We used to go and we used to study that one. They are very much excited to see. Even they told that in Japan also they have mud house, but they do not have the double story. They have a single story kind of a mud house also. So this is very interesting. So we have not addressed properly this material. The second is if you go to the hilly areas of Himachal, again they do not have mud. So they use their local material. They use a local material like the slate or the stone as a material. So this particular also, if you see, these are one of the areas in the Himachal where there is a very low temperature is very low. So thermal damping is very high from that point of view, and the thermal storage capacity is also very fantastic in case of the stone. It actually store a lot of, because it has a high thermal capacity, so it can store a lot of heat, and it can be used in case of the when night time also. But there are still some problem. The problem is, again, the opening is a problem we have not addressed yet. This particular machinery is very prone to collapse in time of earthquake, and the Himachal is one of the area where there is a huge amount of earthquake. Fortunately, after 1992, there was an earthquake in the Himachal, which is known as a Uttarkashi earthquake. In that, there was a lot of damage. After that, Government of India and some scientific research from the Roorkee IITs and all, that time it was not IIT, Roorkee, they have initiated, and there are some thought, some kind of a things, or some scientific interventions was there, retaining the stone as a stone. What slight change you can do that will help you in time of earthquake, that was made. But that was very, it's good to see that kind of a thing has been made, but not lot of research has been done. Go to Rajasthan. There is another set of examples of the climate responsive architecture. That is a hot and dry type of climate, not humid. So in that hot and dry, we do not require larger openings, because we do not allow the air to come in. So, but we need shading. We need some kind of, even if you see the particular, not the climate point of view, but the society point of view, they need some kind of a parda. Parda means there should be privacy. So privacy and the shading come to a infuse together and create a jali, that type of work, the jharokas and all, where anybody can sit with behind a jali, enjoy what is happening outside in a kind of a private manner, and also that jali will give a shading to him or her, and that will be protecting him or her from the direct solar gain, which is very, very tough or the tedious in those areas. There is a jali also. If you see in the Mughal times also, there are a lot of jalis that has been used, and that was actually taken down to the Rajputanas and all. So those are the typical the character of the hot and dry climatic zone. And if you see this jali, one thing is that the jalis are very, very intricate decorative. You see that we see picture, we take some kind of a selfie and all, background and all, because it is very decorative. See this particular thing, it is a Mughal jali, it is very decorated. So that is one part of the thing, one part of the story. The second part of the story is that the jali was made by stone. The stone is having high thermal mass. So if the air passes through the stone, there is a contact of the stone and the hot air, there is a chance of, or there is a high chance of thermal interchange. Number two. So I want to have a higher amount of time to contact with the air to the stone, that I required, because then if the time duration of the contact duration between the air, passing air and the stone is increased, then the heat exchange also going to increase. So what will happen? The hot air will be little bit cooler, maybe 1 degree, 1.5 degree, some 0.75 degree cooler. That is more, very much from that point of view, cooling point of view. Now to increase the surface area, increase the contact time, I have to increase the surface area. Then only, and if you increase the surface area, you have to make it decorated, make it kind of a decorated. Otherwise, how you can make it the surface area increment? You just make a small hole, the surface area is this much thickness. But if you can create some kind of a ups and downs and all those kind of thing, the surface area is increased. As and when the surface area is increase the flow of air will through that, the contact time is increased, and contact time in increase means the drop of temperature is going to increase, because the stone will eat up lot of heat. So it's a match. You may say that it's very decorative and they did, yes, it is decorative, but the science behind the decorative part is that it is required for the cooling. And also, if you provide small amount, small amount, instead of the large holes, small holes, and then your privacy will be remaining. And as and when there is a small holes, there are a lot more surface area. So privacy and the science will be matched with that. So that is the way they have thought of, and that kind of that kind of mechanism. Now again, when you go through which type of stones, and it's a sandstone or maybe it is a kind of the marble stone, that has to be chosen from the material point of view. So those are the some of the, yes, this is the climate responsive housing of Kerala. If you go to the Kerala, entire different set of typology you will see. They have a maximum exposure in the north and south to reduce the heat gain. They want to capture the wind because this is very sweaty, because this is hot and humid kind of thing. So blows air through the air will give you some kind of relief because it is evaporative cooling. The opening are segregated opens and very segregated plan, not very much dense plan, large courtyard, those things are very much important. So if you see this particular building is your Chittor Palace, which is very near to Cochin. Very small, decent, cute looking palace of kings when they go and they sit over there also. See the veranda, see the top veranda, top part at the first floor veranda. You see the design of the window. Maximum opening has been kept. In the window, in wooden window, what you see, there is a hinge, and hinge will come and it will flush with a central stick. That is called mullion, the central stick, and the panel will come and directly put over there. Here that mullion is also vanished, the central piece is also vanished. The particular two leaf will come and all together it will going to join. So mullion will again provide some kind of a barrier to the wind. So if you can remove at least how many 10 mullions, there are much more amount of the airflow and much more visibility. In front of this particular window, which is in the this point, there is a huge lake. So there is ample amount of the evaporative cooling potential. You see the picture below. In this, the right hand side, there are some windows after this particular shaded long corridor, and that particular window is also having larger openings. I mean, opening in the sense very less amount of interference, so they allow the wind. So the ventilation is one of the major character in the in the architecture of the Kerala, which is placed to be the climate sensitive from the warm and humid point of view. Maharaja of Travancore has again constructed a palace called Padmanabhapuram Palace. It is around 50 kilometers down south from Trivandrum. And after maybe another 10 kilometers it is Tamil Nadu, and then it is your the last tip, that is Kanyakumari. So this particular wooden palace, it is a wooden palace, it is a worth to see this particular palace in Kerala, which is having different shells and different character. Architecturally marvelous, because if you see the actual palace, there are different reception hall, then the living quarters, then dining areas, kitchenette and all. But the most important part of the thing is that it's the best utilized the way a climate sensitive architecture could have been. It's erected in, and the material, most prominent material is the is the wood. So I don't have the photograph of that, but it is very much available of in anywhere in the internet. We used to visit this particular palace with our students in 2017.